Hello. Thank you very much, everybody who's joined so far. I'm Jonny Longden. I also have Sandeep Shah on here as well.
Yes, hi everyone.
Okay, let's get going. All right. Thank you very much, everybody who's joined. Great to have you on the webinar. If you didn't hear me when I first joined, my name's Jonny Longden. We also have Sandeep Shah from Webtrends.
Yes, hi everyone.
We'll do a bit of more of an introduction in a second. So we're talking to you today about experimentation statistics, and particularly how to understand the rudimentary aspects of statistics if you have no inclination to get really involved in heavy maths and things like that. That's ultimately the point of the presentation. So just first of all, a bit of an introduction. First of all, I'm Jonny. I look after the conversion division of Journey Further. Journey Further is a performance marketing agency. I've been in conversion optimization since it was invented about 13 years ago, and I have run agency teams. I've been a management consultant, and I've also worked client side at places like Sky and Visa. And along the way, in any of those guises, I've helped some very big organizations put experimentation at the heart of what they do and help them scale that in-house. I started up the conversion division of Journey Further because I have a very fundamental belief that conversion optimization is not respected in the way that it should be, and that it can provide a lot more value to people than they mostly realize. And really, we exist to help organizations embed experimentation in what they do internally, and to help them up their game. So that's what we do. If you don't already, follow me on LinkedIn. I post quite a lot of stuff that's of interest to CRO people on there. Sandeep?
Yeah, hi everyone. I'm Sandeep. I run the product team at Webtrends Optimize. For those who haven't heard of us, we're an A/B testing and personalization vendor. Have been in the space probably for 20-ish years now, probably one of the kind of first tools on the market to kind of play in this area. I get to do all the fun stuff basically at Webtrends Optimize, which is great for me. So kind of R&D, looking at what we build as a product and why, what others are doing, what technology is kind of making available for us to look at, all the fun stuff. Yeah.
Great, thanks, Sandeep. So what I'm going to go through today is this really. So first of all, the challenge of understanding statistics, which is basically why it's hard to understand, but also why you need to, and why that's a bit of a difficult situation to try and approach. Then why it's important that you do understand it to a certain degree. Before we go into what is most of the presentation, which is a kind of a story that tells, and I think an easier way how to understand the fundamentals. And we'll finally look at therefore, bringing all that together, how you use A/B testing as a decision support tool. Sandeep is going to fire in with some questions, and he's also going to watch for if any of you have got any questions. So if you do have any questions, please feel free to stick them in the chat, and Sandeep will interrupt me. So first of all, the challenge of understanding statistics. Well, I see from the registrations there are a lot of people on this who probably already work in conversion optimization, some who work in other roles that need to understand what's going on in conversion optimization. But at the end of the day, for the vast majority of people, the statistics of A/B testing can be very complicated. And I often liken it to a vortex because really there's a bit of a tipping point where once you kind of really go down the rabbit hole of what the statistics mean and how to understand them, you kind of get very quickly sucked into a very complicated world that's really quite hard to understand. And most people, when they start out looking at A/B testing, will probably kind of get a sense of that and just instantly think that's not for me, and will run in the opposite direction. But the issue is that you really do have to find a balance, because if you really don't understand any of it, then you're going to make some pretty big mistakes. And this here on the top right, I'm sure most people won't need explanation as to why this is ridiculous. But when you run an A/B test, you're really looking at the conversion rate of a variant versus the conversion rate of a control. And in this example, there are only 4 sessions in one of the variants and 2 sessions in the other, and they've both got 1 transaction. But that means that you've doubled the conversion rate. Now, that might seem ridiculous to a lot of people, but I promise you, I have seen big organizations making pretty much exactly that mistake, and not really in that much of an exaggeration. But there are much more subtle ways to make exactly the same mistake. And so the problem is, if you run away from it entirely and you don't think about it at all, there's a good chance that you're going to make these kind of mistakes. And really how that plays out is you will see people running A/B tests and just blindly taking what the A/B testing tool itself says is the answer to the experiment. Now, A/B testing tools aren't giving you wrong information. They're only giving you part of the information. And so doing that will generally lead you to base your decisions off incorrect results. If you allow yourself to go right down the rabbit hole, you're going to get into a very, very heady world of some very, very complicated maths. And if anybody's ever tried to do this, what happens is you'll start to look at, okay, well, an A/B test is really an expression of probability. There's statistical significance involved in that. What's underlying statistical significance is something called a p-value. You then look into a p-value, and you're going to start getting into some very complicated equations, and that gets deeper and deeper. And really, it can get infinitely complicated. There's always something else you can uncover, and for most people who have neither the time nor the inclination to understand that, it very, very quickly becomes very complicated. But at the end of the day, A/B testing is a decision support tool. And so you have to find a balance. You have to be able to find a balance where you understand enough of the statistics to understand what it's telling you and how to use that information, but without being overly simplistic about it. So that is ultimately what this presentation is about. It's about how can you understand just enough to make sure that you're doing it right, to make sure that you're making the right decisions off the back of A/B tests, without getting bogged down in the real sort of complex part of the statistics. So I am going to tell you about how I use A/B testing statistics and the results of them. I'm not going to tell you anything about p-values or any kind of real sort of mathematical statistical concepts. So I just wanted to be clear about that. There may be people who do have a reasonable background in statistics. This is truly a 101. It's really designed for people who have no knowledge of statistics. They understand what an A/B test is, but they want to understand how to use the results without having to bother going and doing a degree in statistics effectively. That's what we're about today. So firstly, why is it so important? Well, first of all, A/B testing is effectively risk management. And let me explain that. So, when you're doing A/B testing, you're typically focused on web development. And web development is about developing various different ideas for your website that will have an impact on the revenue. So this is a sort of a simplistic view. Imagine you have 10 ideas of things that you're going to develop over the course of a year or a quarter or whenever. And if you're not doing any testing, then as most people probably know, some of those things are going to work, some of them aren't, some of them are going to have a detrimental impact. This is a fact of life of web development. And really, you only see that truly when you start doing experimentation, because you'll see that not a lot of tests have a positive result. So the reality is you're doing lots of stuff on your website and not that much of it will work. But you are paying, and this is the dev line there, you are paying to develop those things that are ultimately not going to work. Sometimes you're paying to develop things that are going to have a detrimental impact. So doing any form of content or web development at all carries risk. because you're going to pay money to do things that not only might not work, they might have a detrimental impact. So it is fundamentally a risky thing to do. And decision making around this is designed to try and reduce that risk. So experimentation really is providing a layer where what you're doing is, number one, testing the things that you think you're going to do to your website before you do them and figuring out whether or not you should bother doing them. And therefore, you're removing the risk associated with doing things that might damage your conversion rate. But also, when done properly, you should be developing those ideas in a more efficient way, so spending less money on it. But there is still risk associated with that because you are always paying money in some way to develop a test. So ultimately, even though you're testing, the test itself has a slight risk associated with it. And all of this is basically factors that go into how you make a decision. Should you do this thing to your website? Should you test whether to do this thing to your website? And if you do, how confident do you want to be in the result that you're seeing? And that's what I mean by risk management. The other aspect of it is that an A/B test is ultimately what's called sampling. And sampling is a purely statistical thing. So A/B testing is nothing but a statistical endeavor because you are looking at a sample of data and inferring something about the population as a whole. Population is a term referring to a wider set of data. So your sample is a duration of time. You're running an A/B test for a specific period of time, and you're trying to infer something about the result of that and what that means for all time. So I've run a test for 2 weeks. It gives me this result, which is an uplift, and I'm going to try and infer then that that's the result I will see if I push that thing live forever, i.e. the population. And for that reason, A/B testing is completely statistical thing because the inference of what will happen as a result of something that you've seen as a sample is a statistical calculation about probability. Now, the other factor of that is that really you don't know that the period of time in which you're testing is the same, is constituted the same as the rest of that period of time. And in this example, you can see that the traffic volume is quite different in the period that we're testing to the rest of time. So therefore, probability becomes more important because you're trying to infer something about a very different period of time. So
it's also quite challenging, isn't it? Because people change over time, user behavior changes over time. And so you're kind of trying to predict from a sample of, say, 2 weeks or 4 weeks where you're running a test, will people respond to this in the future as well, without actually knowing exactly how people will behave in, say, 6 months or a year from now.
Exactly. And also the people who come to your website during the period when you've tested could be very different people for whatever reason. You could have different type of traffic coming for that period of time. So again, the point of this is saying that you're making a statement about the probability that something you have seen in a given period of time is really what you will see over the rest of time. And then really the ultimate reason this is important is this. Now, on the left-hand side here, we're looking at Google Optimize. And Google Optimize will tell you when a test has run, as most test tools do, but it's a bit more kind of bold in Google Optimize because it says we have a clear leader, deploy the leader. And it gives you a button to deploy it, to push it to 100%. And I honestly do not know how Google Optimize do that, what the logic behind it is. But on the right-hand side, and I'm not going to go into too much detail about exactly what this chart is that you're seeing, but this is a different technique that we use to measure tests. And basically, if that line crosses the green line, then we have proven the hypothesis. If it crosses the red line, it's not proven. And in the middle there, the result is nowhere near statistically significant. And this is a real example where at 3 weeks, Google Optimize said, this is one, deploy the leader. But because the way we measure it, which is separate, it wasn't looking significant. We carried on running it. And after 9 weeks in total, the actual result that we got with more robust statistics was actually a minus 4% on the conversion rate. And that is what's called a false positive. And that's what happens when you stop tests too early. And most people who start out in A/B testing will run tests in A/B testing platforms, and the vast majority of A/B testing platforms will tell you a statistical significance. And Google Optimize does something else. I think it sort of says, let's wait at least 2 weeks and then look at statistical significance. But that is not enough. And that's what I'm going to show you. That's why I'm going to show you. And basically, this is what's called a false positive. You are assuming that this has won when it hasn't. And the knock-on effect of that, which is very common, is that you see CRO teams, CRO people who are running tests, getting lots of winning tests, pushing things live. But then after a year or so, they'll look at the conversion rate and go, well, the conversion rate hasn't actually changed. Nothing's really changed. We're not making any more revenue. And that typically is because you're getting a lot of false positives because tests are being stopped too early and things like that. And that is through not properly understanding the statistics. And that's what I want to try and help you with. So hopefully that makes sense. So in order to explain this, I'm not going to talk about A/B testing at all. I'm going to talk about a different example. And I'm just going to work through a bit of a story without actually really talking about the statistics themselves per se in any complicated way, that I just hope will illustrate how this works. So a fairly common example that's used to do this, but flipping a coin. So I'm going to use this as an example. And really, what I'm talking about here is trying to understand the probability of a coin landing on heads. So just a concrete example, my kids, I have 2 boys, 4 and 7, and they, with boys that age, everything has to be fair. Everything's about fairness. And so, who's going first in a game that we're playing or whatever, we tend to flip a coin. And I've explained to them that that's completely fair because it can either land on heads or tails. But genuinely, one of my youngest boy, he kind of once said, what if, it always seems to land on heads and Jake's always heads. So he's kind of questioning the probability of that. So let's say we wondered, well, I wonder if the probability of coins landing on heads really is 50-50. Maybe it isn't. Maybe there's something about how a coin is weighted that means it's not quite 50-50. So what we want to know is, what is the actual probability of a coin heads whenever it's flipped? And that is really what an A/B test is. You're looking for the probability of something happening. So let's say we decide to do that and we flip a coin 6 times. And that is a sample of data. So I'm using 6 coin flips in order to infer something about the probability in general. And so I flip the coin 6 times and I get 4 heads and 2 tails. And you can imagine that feasibly would happen with 6 coin flips. So it is the probability of the coin landing on heads 4 out of 6. Well, I'm sure nobody would think that. Of course it isn't, because we only flip the coin 6 times. And so the result that we get is complete chance, and it's error of chance, because we've only flipped it 6 times. So we haven't used the right sample in order to understand the probability. And therefore, what we need to do is remove the error associated with chance. And 6 flips isn't enough. Now, what we really want to know is the probability of a coin landing on heads any time ever, in every single time you flip it. So in purely theoretical terms, we need to flip the coin an infinite number of times forever in order to understand the probability. Now, obviously, that's ridiculous. You can't do that. So let's assume we step back a little bit from that and we say, all right, let's flip the coin 10 million times, which is tons of times, right? And we in theory, will have enough flips there to get a really good angle on the probability. If it's 50-50, we'll get 5 million heads and 5 million tails. But if we get, if it's different, then should be enough volume for us to tell that. So let's say, then we try and do that. Well, if flipping a coin takes about 1.5 seconds, then that's either going to take me 173 days of 24/7 coin flipping to get 10 million flips, or I could hire 5,000 people to do 3,000 flips each over about an hour. But assuming we might want to pay them about 200 quid each to come in somewhere and do it, then that's a lot of money, right? Or a massive inconvenience. So is it worth doing? No, not at all, right? And here's the nub, because what we want to then try and do is understand how many times do we need to flip the coin in order to give us a result which is good enough for what we need. Now, let's say that actually I thought, well, I'm going to do this, and if I can prove that coins are more likely to land on heads than tails, that's maybe quite interesting. It might be able to kind of sell that to a newspaper or something like that, because people are probably quite interested in that something that they thought was 50-50 is not actually 50-50. So there is a bit of like benefit to me doing this, because I might get some, might get a bit of money out from it in a newspaper or something like that. So there I can see like the potential reward that I'm going to get from doing this. And then the question is, what effort or money am I prepared to put into finding out the answer? And how confident do I need to be? And how good is that? So that's really like, what ultimately an A/B test is. You're trying to get the answer for whether you should do something or not, but in a way that's good enough based on what you want to do with it. And a lot of people forget that.
Is there a suggestion, Jonny, on your side as well? So let's say the cost of finding out the answer feels like a lot more than the cost of doing it. Or the potential uplift. What would you suggest? What would you kind of use as a decision factor to say, should we go and do it anyway? This kind of argument of don't bother testing, it's not worth it, basically.
Yeah, well, I mean, unfortunately, that's something that there isn't really any hard and fast kind of instructions and rules that you can give people about how to do it. In actual fact, there is. So there are tools that you can use to calculate the kinds of parameters you should use in a test based on risk and reward scenarios. Those exist, but they are very, very complicated, and you really do need to understand quite a lot about statistics, probability theory, and stuff like that, and how the risk reward is calculated, if you're going to understand what it's telling you to do and to trust it. So without going down that route, really, the reason there isn't really any kind of good rules and rules of thumb around it, or it's quite unique for different businesses. I'll come back to this in a bit, but really it's about, number one, understanding this, and then two, figuring out your own ways of having some sort of business rules around it. But you can also just use gut feel when you do it a lot. You get into a kind of a rhythm where you can sense, this is got a lot at stake. So we're going to need to be really confident. We need, blah, blah, blah. This doesn't. And really that's probably the way that most people are going to go about it. But I'll come back to that. So when we design an experiment, first of all, we need to understand what it is we're actually trying to prove. And let's say I have that theory that, maybe I can sort of sell this to a newspaper or something. I might decide that I want to prove that heads are going to land, that the heads are going to land 55 out of 100 times. And so therefore, actually, if your assumption is that heads and tails are 50-50, that's a 10% uplift on that. Now, that's really key, because that's what you call the minimum detectable effect. And a hypothesis you test always has to be based around that. So you're looking for a particular uplift. And then, given that I can't flip the coin 10 million times, I have to accept that I can't be totally accurate. But then how confident and how accurate do I want to be? And there comes the next question. What is my appetite for risk? What am I prepared to accept as risk in terms of the result that I get being wrong? And I might therefore go, okay, well, I'm going to accept a 5% error rate. Now, what that means is that if I do this exercise and I flip the coins however many times I'm going to figure out I need to flip them, and then I get my probability and I go and tell the world about it, there's a 5% chance that that is wrong, that I'm giving incorrect information to people, because the result is totally different. And the result that I've seen is because of chance. Now, that's the same as saying 95% statistical significance. And that's what statistical significance is. It's a margin of error. But that error is basically, there's this percentage chance that the result I'm seeing is not, that result is not real. And so that allows me to flip the coin, to calculate how many times I need to flip the coin. And I'll show you this in a bit as well. But I know there I need to flip the coin 1,000 times. So I'll get 5 people to help me do it. We'll just do 200 flips each. It'll take us about an hour. And so we start flipping the coins, and we start counting the result as we flip the coins. So after not very long, we notice we've done 300 flips between us altogether, and we've got 173 heads. So that's quite a considerable uplift over 50-50. There's more heads than there are tails. It's actually a 13% uplift over 50-50. And the statistical significance of that is 95%. So that's more than 10%, and we've already got 95% significance. Should we stop flipping? Should we go, okay, well, we've proved what we wanted to prove? Well, absolutely not. Because the statistical significance there is irrelevant because we haven't achieved the sample size. And that's really, really, really important. That's the most kind of important thing that should be the takeaway, really, because if you run an A/B test and the tool will tell you that you've got 96, 97% significance, that is irrelevant unless you have achieved the right sample size. And the vast majority of A/B testing tools do not have any notion of sample size built within them. Some of them do, most of them don't. They give you the statistical significance, which is only one part of the picture. And that's because to calculate sample size, you have to determine your minimum detectable effect and the confidence that you're going for before, and then you calculate the sample size. So this is how a lot of people go astray, because they will look at the A/B testing tool. It says the significance is 97%. Let's stop the test. And that is stopping the test early. So in this case, if we just stopped that there, we would have had potentially a false positive.
Just a couple of kind of relevant questions, Jonny, as well. So Brad's asking, is 95% the standard number to pick? Perhaps assuming we've hit our sample size, for example.
So 95% is a kind of a sort of a dogmatic kind of thing in the industry, that people think you have to have over 95%. You actually don't. You've got to remember that's a statement of your appetite for risk with that particular test. So if you think of it like that, the idea that there is a completely industry-wide standard of 95% is absolutely ridiculous, because how can there be an industry-wide standard for appetite for risk for every single test and every single decision that's made? That doesn't make any sense, right? So you have to really determine that for yourself based on what is the situation. And again, it's one of those difficult things where there isn't really a set of rules or parameters that somebody can provide you. It's something that you kind of have to work out for yourself. But, on the other hand, it is quite a reasonable thing to say that 5% acceptance, accepting a 5% chance of error seems about right in a lot of cases. But yeah, it's, I would definitely avoid the thinking that it has to always be 95%. So anyway.
Sorry, one more point just from Brad as well. How again did we get to that number of needing 1,000 flips in this example?
I'm going to show you that after this, so I'll come back to that. So we carry on and we flip over 1,000 times. And the final result is we got 559 heads from 1,050 flips. And that's a 6.48% uplift and a statistical significance of 92%. So from that, are coins more likely to land on heads? Have we proven that coins are more likely to land on heads? Now, 6% uplift is reasonable uplift. 92% significance is a reasonable amount of significance. So can we say from that coins are more likely to land on heads? Well, they might be, but we cannot say that because we have not proven the hypothesis that we set out with. So if you remember, our sample size was based on a design of the test which said that we are looking for a minimum detectable effect of 10% and 95% statistical significance. Now, in actual fact, it wouldn't necessarily matter if the uplift hadn't reached the minimum detectable effect. But what does matter is that we haven't achieved the statistical significance that set the volume. So this test has resulted in an inconclusive result. We have not proven the hypothesis. And it's as simple as that, basically. We haven't statistically proven what we set out to do. So hopefully that helps just explain it in a sort of a slightly more human way than you might if reading about statistics, and the kinds of decisions that you're trying to make. Because if you think about it, really what I was trying to do is decide whether I could get a decent enough result for what I wanted, which was A, to really demonstrate the probability that coins land on heads more, but B, to potentially make a bit of money out of that data, or to make something out of it. And so I've got to be confident in the result, and I've got to be confident in what it's saying. And so that's really what it's about. So there are some really important concepts that come out of this, and sample size is probably the most important one. And as I said before, if you've run tests in an A/B testing platform, and seen that you can get a statistical significance from the result with a percentage, then that is only part of the coin of the situation, because the sample size is in a way quite a lot more important. And the sample size is really the question: how many times do you need to flip that coin? If you remember, we flipped the coin 6 times and we got a ridiculous result. So how many times do we need to flip the coin in order to remove that error? That's the question. And that is the sample size that you calculate. The statistical significance, in a way, is a little bit irrelevant without that, because that's really only answering what's our appetite for risk in terms of the result we get, and not the sample size. So sample size and calculating a sample size is very important. The minimum detectable effect is what you are trying to prove in numeric terms about the uplift. So when you calculate a sample size, as I'm about to show you, you have to say what the minimum detectable effect is. Now, that's a really awkward thing to deal with, and I'll come back to why. Because what's an uplift to go for, right? What's a meaningful uplift that you should be trying to prove? That's not that easy to answer. But then the third point, which is the thing that most people are familiar with, is statistical significance, which is simply what's your appetite for risk in the result. But as I said, it doesn't make that much sense without the sample size part of it, and is really prone to error, because you can very feasibly run a test and 2 hours later get 98% significance, because it will look at the significance without really understanding that sample size. I mean, statistical significance does contain a notion of sample size, but it is not sufficient for what we're trying to do. So what I'm going to do is actually I can't do that, can I? Can I share my screen? Maybe I can. 1 second. So can somebody just confirm to me? Sandeep, can you confirm you can see my screen?
I can, yeah.
Yeah. Okay, so you can find a range of A/B test sample sizing calculators on the web. Now, there's a few little bits of this that are a bit complicated that I'm not going to go through. There are 3 things in here that I'm going to talk about. One is this baseline conversion rate. One is the minimum detectable effect, and the other one is the significance level. And those are the core things that we're interested in. So when you calculate sample size for an A/B test, the first thing that you need to state is the baseline conversion rate. So that is the conversion rate of the experience that you are testing. So that might, if you're running a test on your home page, that is the conversion rate of your home page, and over the most recent period that you can get it. But say if you're doing it only to mobile traffic, then you need to look at the conversion rate for mobile traffic on the home page. So for a lot of people, that's going to be something like 1.5%, something like that. The minimum detectable effect is what you are testing for. And just like I wanted to try and prove a 10% uplift in conversion, or in the coin flip, this has to be stated. Now, let's just for the moment put in here 3%.
I've got a relevant question just on this topic as well from Mossen, which is, how do you work out what your MDE should be?
Yeah, so I'll come back to that in a second.
Okay.
That's a very good question and a difficult question. And then the third aspect is the significance level, and that is the appetite for risk. So this here, it says 5%. It's inverted. We usually talk about it in terms of 95%. But I could say I'm happy to accept more risk. I'm going to go 10%. There is something called statistical power. I'm not going to go into that because I promised I wasn't going to talk about more complex things. It's a different kind of significance. But in a lot of calculators, you won't see that. If you do happen to see that, leave it as 80% for the time being. So these are the 3 different parameters that we can play with that will determine the sample size. Now, the baseline conversion rate is the first thing that impacts the sample size. The lower that number, the higher the sample size. So if I change that to 0.5%, you see that I'm now needing nearly 3 million visits in each variation of the test. The second thing that impacts is the minimum detectable effect. The lower that is, the more volume that I need in the sample. And the significance also impacts. So the more confident I want to be, the greater the sample size. If I want to be 99% confident, then I need much more volume. So here you start to see that it becomes impossible to run tests. Like if I have a low conversion page, even if it's 1%, and I want to detect a very subtle effect with high confidence, I need 23 million visits in each variant or control. Now, unless you're Google or somebody like that, that's going to be very hard to achieve. So herein lies the problem, and this is where you have to play around with the parameters, and this is really what is designing an experiment, because you're trying to understand what you can realistically test within a given period of time. Now, the first thing is the minimum detectable effect. So let's just come back to that question. Now, this is an awkward thing because in real terms, this should be about what is the most meaningful thing to me. And you could say, right, well, it's going to cost us 50 grand to develop this thing if it wins. It's a big project. So you could really work out that you want a 10 times ROI on that spend. You want to make 500 grand or whatever, and therefore you would need to prove like a 10% uplift in conversion in order to make that worthwhile. So you know that you're testing for something which is going to be worthwhile based on the cost and effort of doing either the test and or the thing that comes as a result of the test. That's nice and easy. But in most cases, you would accept anything, right? So in most cases, like, if you're running a copy test that you can do in a tool that you're already paying for, and then when it wins, you're just going to put it live in a CMS, then anything would be worth it. Like 0.5% uplift, if you could prove it, would be worth doing, right? But there's the problem. In that case, I need 9 million sessions in each test. So you just cannot test for that level of subtlety in most cases. And what do you then do? Well, then you just start putting in arbitrary numbers. So you just start going, well, what if it was 12%? And unfortunately, that is kind of what you need to do. And really, rather than having a number here that is meaningful to you, you are understanding that there is a minimum level of impact that you can test for, depending on the kind of volumes that you have. So you might say, okay, well, in this case, I don't want to run this test for any longer than 6 weeks. Because for XYZ reason, because I don't completely believe in this idea. It's not something, we want to kind of get it out of the way so we can test other things as well. Or you might say, this is a really, we believe in this, it's going to have big impact. Let's like really give it a good go. We'll run it for 3 months maximum, something like that. And then you would calculate from the traffic you're going to get, the kind of sample size that would be sufficient over that period of time. So say if I get 10,000 visits a week to the page, I know that I need 5,000 visits in each variant. And if I want to run it for 10 weeks, I need 500,000 visits. So I might then start to play with this and go, so like maybe 6.5. So I know that in that period of time that I want to run that test and the sample size that I'm going to get over that time, I can detect a minimum of 6.5%. Or, I can sort of play around with the confidence as well and say, well, actually, maybe I can be less confident in this. So in that case, maybe I can detect a 5% improvement. And I'll just come back to this when I flick back to the slides, but this is what you're doing. These are parameters, they're levers that you're pulling in order to design a test that fits with your idea of the risk and reward of this thing that you're doing. And again, there's no sort of rules that I can give you about how you do that. It's something that you just have to do with every test, and then you start to get a feel for it, and you start to get a feel for how you should do it.
And if the sample size you would need to detect, an improvement, which is what you end up kind of receiving when you run the test, if you don't hit that sample size, or the MDE needs to be too high and you don't think you're going to get there, what does one do about running the test? Then do you still go for it?
If you do it the way I said, you should be able to calculate. So the traffic coming to the part of the experience that you're testing on, and you can then make a decision as to how long you want to test for. And again, that's something quite unique to different businesses in the way they work. Depends how many tests you run, whether you want them to overlap and things like that. So you should be able to say, this experience that we want to test on gets 10,000 visits a week. I don't want to test it for longer than 6 weeks. So, in each variant, or as a whole, we know we need 60,000 sessions. And so once you know that, and if you decide that, then you can look at what you can feasibly test in that. And if you find out that actually you're only going to be able to detect 20%, then you might think, what's the point? Because this is going to be more subtle. So then you can decide, well, do I run that test for longer? Do I reduce the confidence? Is that acceptable in this case? These are the kind of parameters that you have to play with to arrive at a place. But you should not be in a place where you don't achieve the sample size, because you should calculate beforehand what that sample size will be, and the traffic. I mean, that might happen in cases where your traffic fluctuates in a way that you didn't expect, like you stop sending traffic to that page that you didn't realize was going to happen, and then your traffic drops off. That might happen. But putting that aside, you should be able to know that you're going to get that sample size. The other interesting thing that happens is that the baseline conversion rate makes a massive difference. So if I want to detect a 1% uplift on a page with a 1% conversion rate, then I need 12 million samples, or whatever in this. Now, if that conversion rate was 10% or it was 25%, then that comes down enormously, because the sample size is based on this, and the smaller the conversion rate in the first place, the more samples needed. So what you can do is test on more upstream metrics. So if you think you're usually trying to test for conversion rate, but you could test for, say, like a click-through or just the passage from one page to the next. Now, really big warning about that. Proving a click-through does not prove conversion rate. However, again, based on the risk profile, you might decide that that's an acceptable piece of behavior that you want to demonstrate for. So that is another way to bring the sample size down if you need to. So that's how you calculate sample size. Let me just come back here. So delay here. So ultimately, what hopefully that shows is that you have got risk factors associated with what you're doing, and you need to understand that in order to understand how to play with those parameters and how to design your test around the notion of risk. So the things that go into that, and again, I wish I could give you really kind of clear instructions on what to do with these things, but it's just something that you learn over time. So what revenue is at stake? So like if you're going to make a change to a super high traffic page, the main page of your site or the checkout or something like that, then there's potentially a lot of revenue at stake, because if just a 1% decrease in conversion or something like that would be a lot of money. If that was to happen on a blog page or something like that, probably less impact. So what revenue is at stake on what you're testing? How much is it going to cost you to test the thing in the first place? So do you going to have to pay to build the test? Are you going to have to pay to implement it? So like, you might run a test that's quite cheap, but the implication of it might be that you have to push that through to an agency, and they're going to charge you through or your internal dev team, whatever, they're going to charge you to build it. And that's even worse if what you've tested is just a concept that then leads onto a bigger, different project. You're not just pushing that exact same thing live. What would be the cost to back it out? Sometimes you do things and actually you would have to pay to back it out if it didn't work. And that sort of stuff. And then also, and probably most importantly, like there's a whole aspect of learning around it. So, and this is where you can start to be more flexible about confidence, because when you're running A/B testing properly, a lot of the time you can run tests that really you don't really intend to do anything with that. You're testing something with the purpose of learning something from it to ladder up to something else. So a good example of that would be I'm just running a series of tests for a client at the moment where we're ultimately going to try and prove whether or not they should give a 10% discount to all new visitors to the site. And it's phased, where the first thing I want to prove is just what would be the impact of giving that discount. So I'm going to run quite a short test with a 10% discount offered, just to learn what does that potentially do to conversion. If that works, then what this client will do is basically increase their prices to accommodate for what they're giving away with the 10%. So the second phase of the test will be to understand the negative impact of increasing pricing. If that works, the third phase of the test will be to properly run the test and run it as it would be if it was live. So in that first instance, I'm not going to push that thing live. I'm just testing it to get the data to say, is there a sense in continuing with these things which are more effort? And so I can be quite loose with the confidence on that, because there's no risk really. Like, it's going to run for a short period of time. I can switch it off if it looks terrible. I'm not going to do anything as a result of it. So there's all that as well that goes into it. Like, and that's really one of the most important things that can drive how you view confidence. But just like I said, that is unique to you, your business, your CRO program, how you make decisions, how your business views risk, all that sort of stuff. It's kind of unique. You have to figure it out. But just to sort of try and tie all that together, I'm just going to leave a bit of time for questions. I'll go through this very quickly, but just to try and tie that together, the instructions that there are number one, you have to understand the risk profile of what it is you're doing, how that relates to what you're doing. Two, before you do anything, before you start the test, you calculate the sample size as you're designing the test before you build it or anything, because you're going to work out whether it's worth bothering with at this point as well. Calculate the sample size using baseline conversion rate, MDE, and significance, and make those meaningful to you and what you're doing. And then you have that kind of fixed line of sight. You know how long the test is going to run, you know the sample size that you're looking for, and then you run the test. And you do nothing until you've achieved that sample size. You can look at the test results, but don't do anything about them. Don't stop the test. I mean, yeah, obviously, if you get if you halve the conversion rate and things like that, then you want to be worried. But it's a bit of common sense. But other than that, don't do anything until you get the sample size. And then once you've achieved the sample size, you look at the uplift and the significance. And if the significance is equal or more than the significance that you base the sample size on, then it's a winner. Now, interestingly, it doesn't matter if the uplift is not more than your MDE. And that won't happen if it's really subtle. But if you base the sample size on a 10% MDE and the uplift you get is 9%, that doesn't matter. If the significance is over what you planned, then it's still relevant. So that's the kind of 5 steps to go through. We've only got 5 minutes left, but any questions?
Yeah, we've had a lot of questions in the chat. You may have heard them bubble up as you were.
Yeah, just by the way, if we don't get through them all, I will go through them and I will respond to them by email where possible.
Excellent. Yeah, there's a couple. I know Ashley's been waiting for a while. So I think earlier you spoke about this idea of sampling for your test duration versus kind of population, the duration if you look at an entire year. So Ashley's asking a question on probability then. So for businesses who are reliant on seasonality, so things like Mother's Day or Easter, how would you project the probability of an uplift or success over the coming months? So when the concept is the same, like seasonality, but user types or people are different?
Yeah, so there's no easy answer to that. And really, if you're going to kind of go about it properly, you should probably retest things at different times of year. That's not always that practical, but I'd say the real kind of proper way to do it would be to retest things in different peak periods and things like that. Given that most people probably aren't going to bother doing that, and I'm going to do what I said I wasn't going to do here and get into a slightly more statistical thing, but with the right tools, the right way of doing it, when you have a test and you've run a test and you get the uplift of the test, so I run this test and the uplift I saw was 6%, there are ways of calculating a expected projected version of that using confidence interval levels, which means the right sort of method could say to you, the uplift you saw was 6%. This is expected to be a range between 1%, and 8%. And then you can make a decision as to if you want to kind of make an assumption. You could say, well, I want to be as pessimistic about this as I possibly can, and I'm going to assume that the real uplift there would be the lowest boundary, the lowest boundary of confidence, which would be 1%. And then you can say, if that was real, is this still worth doing? So again, I'm not going into the methods for that, but there are methods of doing that where you can look at a range of possible values over time, and again, based on your own way of making decisions, where do you put that?
Cool. Thank you for that, Jonny. A couple more here as well. One which I'm sure you'll probably show on your LinkedIn over the next couple of weeks or so. But Mohsen's asking, can you share some resources to help understand this kind of phenomenon of false positives a little bit better?
Yes, probably. Yeah, there's probably quite a lot of stuff around that. It's something you see when you do it a lot as well. So if you get, what I would say is, if you can, any test that you get where like the tool says this is the significance, keep it running for another 4 weeks or something like that, and see what happens, and see if it still says that. And that's where you start to learn about what that does. But there will definitely be some. The challenge is, as with this exact concept of this, the challenge is finding things that are not written in a really dense style that are really hard to understand. But I will certainly have a look.
Excellent. A few people have been asking, I think, just up and down the chat. So when you're looking at sample sizes, do you consider sessions or users as your kind of basis?
When you calculate a sample size, there's no assumption within it of whether it's a session or a user, really. So it's up to you how you interpret that. There's a lot of debate about that, about whether you measure a test based on sessions or users. Absolutely, in kind of theoretical terms, it should be users. Your calculation of conversion should be users with a conversion divided by users. But there are so many problems with users, with cookies, and the way that users are measured, that it's debatable whether those problems create too many issues in that. But at least when you calculate the sample size, there is no notion of that within that. It's just a number. It's the number of units, whatever you determine that unit to be.
Excellent. Apologies to a few people. I'm just seeing the comments now. It looks like the slides have gone into split screen. So people are giving my face the same screen time as the slide, which is rather unfortunate.
Is that better?
I think so. Certainly better on my side here. Cool. Yeah, I think we're pretty much hitting our 3 o'clock timer. I don't know if we want to just run through those last couple.
Yeah. So just to finish off, if anybody would like a free consultation to discuss this or anything else about conversion optimization, I am more than welcome, and door is always open. So I think you should see a link to click on if you want to do that. Please do connect with us as well. Like I said at the beginning, follow me on LinkedIn, email us with anything you want, either myself or Sandeep. Sandeep, we've got a bit of an offer around Webtrends if you want to talk about that.
Yeah, absolutely. So as we mentioned, we are an experimentation and personalization vendor. For everyone here, we are offering 25% off our pricing for everyone that's here. If you want to get in touch, whether it's to talk contracts or just have a chat about how good we are or what we do, or how we look at certain issues and what we can help you do, don't hesitate to get in touch. You can see the email just on the screen there.
Thank you. Yeah, so great. I mean, thanks so much everybody for joining. Hopefully it's been interesting. And as I say, just anything you want, get in touch.
Cool. Yeah. Thank you very much, everyone.